Hi everybody, here's your first Algebra 2 video. This is at 1.1. This is actually the very beginning of the course, so this is the first thing that you guys are going to be seeing. So 1.1 is specifically related to what we just did in class the other day, what you would have done a couple days ago. So this is everything that we're doing has to do with that 6-page packet. So anything that had to do with transformations, whether that was a translation, sliding left, down, up, right, stretching, shrinking, flipping, whatever we're doing, all of those things have to do exactly with that 6-page thing that we did the other day. I know that this is something that you guys did in Algebra 1, so this should be kind of review, but it's just kind of a jumping into a couple of different things and applying what we already know to it. All right, so the way that we're going to work on this is exactly like we do in class. I have my little tablet here that I'm going to be writing on, so I'm going to write my notes down on the board, and hopefully you can hear me. In my practice, the voice kind of cut out for a second. You could still hear it, you just had to turn it up, and then it got really loud after a second, so just kind of pay attention to that. Hopefully it all goes well this time. But I'm going to share my screen so that you can see what I'm talking about with my notes, and then once we get into the notes, then hopefully everything is going to be good. So chapter 1.1, which is what this is, there's section 1.1 is all about parent functions and transformations. My handwriting on this is even worse than it is in real life, so I apologize. But this is about parent functions and transformations. Now, what I want you to realize, you already know what a transformation is. You learned it in geometry, you learned it in Algebra 1. It's basically you take something and you move it or change it in some way. A parent function is something that may not be as fresh in your memory, but a parent function is basically the most basic form of a type of function. So this is the most basic form that you can possibly have. And then what we do is we take those parent functions, those basic form functions, and we move them somehow to create the new functions that we're specifically talking about. So that's what we're doing in these types of questions, just to kind of keep that in mind. All right. So I'm going to go over those 4 types of parent functions from this chapter that we're going to be dealing with. The first one is a constant function. And that just means that it's not going to move. It doesn't have any variables. So this is the constant function would just be something like f of x equals 1. And that would look like this. It would go through the line 1 and then it would just, or the point 1, and it would look like that. That's just a very common one. The only thing we can do to that is move it up or down. That's it. We can't do anything else with it. And the only way that it moves up or down is by changing this number. The next one is called a linear function. And you all know what a linear function is. The general form of a linear function is y equals mx plus b. But the parent function is just going to be x, because all it does is goes through the origin and then it goes through those points. So when I have a linear function, it's just a line that looks like that, going through here and up. My line isn't very good, so you get the idea though. So it's just a general function. Now we can change that by changing the slope and by changing the y-intercept. That's really all that changes. So we can put a number in front of here, which changes the slope. We can put a number here, which changes the y-intercept, and that's how we transform those. The next one is absolute value. And an absolute value function's equation, general equation, is f of x equals the absolute value of x. So now this is just going to be a function that goes this way and it goes this way. It looks almost exactly like a quadratic function, except it comes to a point and it's not rounded. We can also change this as much as we want. We can put a number in front and that will change vertically or horizontally. We can put a number here, which will change the location of the vertex left or right. Or we could put a number back here, which would change the direction of the vertex up and down. So the last one that we have to deal with is a quadratic. And we all know what quadratic is, because quadratic is just when we have a squared value. So we have the absolute value, or not absolute value, but we just have x squared, which that makes the parent function look like this. Now it looks very similar. It's just got a rounded bottom down here. It still has a vertex. The vertex is still at 0, 0. Vertex is still at 0, 0, and we're good. Now the thing that we have to pay attention to is domain and range. Domain and range is a big idea that keeps popping back up in this book over and over. So just think about that. For those of you that don't remember, the domain is all possible x values. So for instance, in each of these, I would take my pencil and move left and right throughout the entire graph and see if there are any spots that my pencil would not touch a line. So see how my pencil, no matter where I move, would touch a line no matter left or right how far I go. That means that every single number will work. So we'll say all reals. Actually, I'll write that in a different spot so that doesn't confuse you. So the domain here would be all reals. The same thing is true here. No matter how far left or right you go, the domain will be all reals. Now, if we look at the range is the possible y values. And if we have the possible y values, now I just move up or down and see where my pencil won't touch line anymore. So up here, see how my pencil will constantly touch line all the way till I get to 0? As soon as I get below 0, as soon as I get down here, my pencil will no longer touch that. So my range is going to be y has to be greater than or equal to 0, because as soon as I get lower than 0, I won't touch any pencil or any line anymore. Same thing happens down here. So this is still y is greater than or equal to 0. So my domain is all reals, my range is y is greater than or equal to 0. You're going to find out that in this first chapter, the biggest thing with domain and range has to do with those values. Okay? So now as we move on, we're just going to talk about the transformations. We already know what a transformation is. A transformation is when we take a shape or a graph and we change it. So I'm going to show you exactly how we graph one of these, and I'm going to show you just based on a complicated one, because if you understand the complicated one, the easy ones are just super easy. I'm not going to waste your time showing you how to graph a line because you already know how to graph a line. You just find the slope, you find the y-intercept, and you graph it. So I'm not going to waste your time with that. But if we have a function that says something like this, it's f of x equals negative absolute value of x plus 5 minus 3. If we have something like this, the first thing you do is identify what kind of function it is, and this is an absolute value function. So what I would do is I would write down what my parent function is. So my parent function looks like this, and I would graph my parent function. All of these questions ask you to graph this along with its parent, so I'm going to throw a graph paper on here so I keep things as consistent as possible, and you can see what it looks like. So I'm going to draw my parent function. My parent function will start here. Oops, hang on a second. So my parent function will start here and it will go this way and this way. And that's the absolute value parent function. So I know that. If you want to know what the domain and range are for the parent function, you can very easily remember that from the beginning, and that's domain will be all reals and the range will be y is greater than or equal to 0. Now, if we go through, I like to do this because most of the times I'm going to ask you to do this is without a calculator. Your calculator can do it for you, and I'm not interested what your calculator can do. So I'm doing this in terms of you're not using a calculator. So I'm going to start this by putting down an XY chart of the parent function. So that means what the possible X values are and what the possible Y values are from this function here. So that I pick 3 points, and I pick the 3 most defining points of this function. The first point is going to be 0, 0. That's the vertex that shows up right here. My next point is going to be 1, 1. So 1, 1, and then my final point is going to be -1, +1. So -1, +1. Now what I'm going to do is just apply all of the things from up here that I know are going to happen. Okay, so I'm going to go back to my original function, or the new function that I want to draw, and I'm going to apply these things one thing at a time. So we had talked already. I know that when I have a negative on the outside, it's going to flip my function. So this function on the right side is going to flip this way. That means that none of the x's are going to change. It's not going to move at all horizontally. It's going to start up here and it's just going to flip down. Every one of these points here is going to mirror image. So this point is at 1, it's going to become -1. This point is 1, it's going to become -1. So all I have to do to make this really, really easy is I look at this column right here, and I'm just going to take the opposite of that y column. So the opposite of 0 is 0. The opposite of 1 is -1. The opposite of 1 is -1. Now, I like to go through and I like to cross these off because I don't really want to deal with them anymore. So I'm going to cross off all of the columns that I'm not using anymore. Okay, so now I'm going to continue on through. This thing in here is going to apply to the x's. Remember, according to that paper that we had yesterday, those x's, if we add a 5 inside with the x, it shifts the graph to the left. So I'm going to look at my x column and I'm going to shift it to the left. In order to shift a graph to the left, I'm going to subtract 5 from all of the x's, because moving it left will be taking away 5. 1, 2, 3, 4, 5 to the left. Okay, so I have 0 minus 5 is negative 5. 1 minus 5 is negative 4. Negative 1 minus 5 is negative 6. And now I'm done with this column. Feel free to pause the video at any time if I'm going too fast. And then finally we have this, which shifts the graph down. So I'm going to take my most recent y column and I'm going to shift the graph down 3 units. So I'm going to take that column and I'm going to shift it down 3 units. 0 minus 3 is negative 3. Negative 1 minus 3 is negative 4. And finally, negative 1 minus 3 is negative 4. I'm done with this column. So now I've got my new function. I've got this function. This is my x column. This is my y column. So now I'm just going to regraph that. So I'm going to go up to my parent function. This is what I'm graphing. These are the points that I'm graphing. So I shift it left 5, 1, 2, 3, 4, 5, and I go down 3, 1, 2, 3. I look right here. Now I'm going to do the same thing with negative 4, negative 4. 1, 2, 3, 4, 1, 2, 3, 4. It's going to be down here. And then the point negative 6, 4 is over here somewhere, and then down 1, it looks like this. And I now have, oops, that wasn't a very good line, but you get the idea. Those. So that's my graph. This graph has been flipped, shifted left 5, and shifted down 3. Now the last thing I want to show you is what happens when you have a function where you are changing the stretch or shrink on it. So if I look at an equation that looks like this, where it's f of x equals 1/2 x squared, I know that my parent function is going to be x squared. So I'm going to go with my parent function, make my table. So I'm going to do 0, 0, 1, 1, negative 1, positive 1. And then this 1/2, all it's going to do is it's going to affect the y's because it's a vertical stretch. It's a vertical stretch or a vertical shrink. If it was happening inside, and when I say inside, I'll erase this in a second. I'm talking about inside attached to the x squared. You see how this 1/2 is not attached to the x squared? If the 1/2 was in here, then I would get rid of it. Or then it would be a horizontal stretch or a horizontal shrink. Okay, so now in order to apply this right here, all I'm going to do is I'm going to do 1/2 times my y column. So I'm going to get 0 times 1/2 is 0, 1/2, and 1/2. My new function here would be, this is my x column, this is my y column. So I would graph these points and these points. Okay, so I'm hoping that that is enough. You have some homework on your Google Classroom that you can go check too. It's basically just going to be practice at this point. So every one of these questions deals exactly like the question that I just dealt with you on. You just have to apply them to what you know the table does. If it's x's, make it only deal with the x's. So if it's horizontal, it only deals with x's. If it's vertical, it only deals with the y column. I always try to cross off the y column so that I know which one I'm dealing with. I always try to cross off whichever one I'm not using to not confuse myself. If you notice, I only have 2 active columns at a time. Okay? So if you have any questions, don't hesitate to let me know. I hope that this is a pretty straightforward, pretty brief video. If this is something that you can kind of skip through, that's great. If it's something that you need to rewatch a few times too, that's okay. Please make sure that you talk to me and ask me if you have any issues, because I'd like to be able to talk to you about it so that way we know exactly what's happening. Okay? So let me know if you have any issues. Good luck and have fun.